Yeah, I want to show you something you've probably never seen before with long division. So here's the algorithm you were taught in elementary school. Typically for 7 divided by 2, we would put a 3 right here because 2 will go into 7 3 times without going over. But we don't have to put a 3. We could put a 0 right here. And we can even put random numbers in these locations. This may not look or feel right, but this is valid math, and I'll show you why. The 7 right here will go on the inside, and the 2 will go on the outside. How many times does 2 go into 7? 3 times. To multiply, 3 times 2 is 6. Step 3 is to subtract. 7 minus 6 is 1. And now that is our remainder. If we want to do the same problem without a remainder, we can put a decimal point and a 0 there, bring the decimal up. Same thing, 2 goes into 7 3 times. Multiply, subtract, we get a 1. We can bring down this 0. And 2 goes into 10 5 times. And then 5 times 2 is 10. We subtract and we get 0. So now there's no remainder. Both of these are correct, even though they look so different. Let me explain why. First, let's do some vocab. This 7 is called the dividend. The 2 is called the divisor. This 3.5 up here is called the quotient. And then whatever's left over is called the remainder. We need this to be true. This divisor times this quotient plus the remainder has to equal the dividend. If that's true, then the math you did is still valid. So we can check both of these. If we plug in 2 for the divisor times, and the quotient is either 3 or 3.5 plus, and the remainders, and that needs to equal 7. And that's true for both of these. 2 times 3 is 6 plus 1 is 7, and 2 times 3.5 is 7 plus 0 is still 7. So that is why both of these work. So now let's talk about that crazy one. Instead of saying how many times is it going, let's just literally put any number we want. So now let's verify it with this equation right here. So our divisor is 2 times our quotient is this 0.3814 plus this remainder needs to equal 7. Well, 2 times 0.3814 is 0.7628 plus this guy again equals 7, and these two do add up to 7. So this is true. This is a valid way to calculate this. Now, why would we ever do it this way? There are a couple cool things that follow when you deviate from that standard algorithm. For example, I did another video where I did 1 divided by 1, and I showed that it was equal to 9 repeating. Notice that there is no remainder accumulating. The remainder keeps getting cut out by all these repeating 9s. So when we're done, and we have this here, we have a divisor, our quotient is going to be 0.9 repeating. Just imagine this goes on forever, but there's no remainder. The remainder is 0 because there's nothing here. In our other problem, it had this 0.62372 because we weren't getting rid of the remainder. It was sticking around. But for this one, the remainder is not there. It's getting taken care of by all those 9s. So we have no remainder. And then our dividend needs to be equal to 1 on the inside. Well, 1 times 0.9 bar is just 0.9 bar, and then 0.9 bar plus 0 is just 0.9 bar. So we can conclude 0.9 bar equals 1. What I like about this demonstration so much, you can see those 9s accumulating and how they're taking care of the remainder. It gives some really cool insight into 0.9 bar repeating equals 1.